The pursuit of understanding the fundamental building blocks of our universe often sparks a blend of awe and intense anxiety. At the center of this dialogue is the European Organization for Nuclear Research, commonly known as CERN, and its massive Large Hadron Collider. This 27-kilometer underground ring uses nearly 10,000 magnets to accelerate protons to 99% the speed of light. By crashing these particles together 10 figures of times every second, scientists recreate the extreme conditions that existed moments after the Big Bang. While this research led to the monumental discovery of the Higgs boson, it also fueled global headlines suggesting that humanity might inadvertently engineer its own destruction by creating a black hole. To understand the risk, one must look at how black holes are formed. Typically, these cosmic vacuum cleaners are the remnants of massive stars 20 times the size of our Sun. However, theoretical physics suggests that if enough matter is compressed into a small enough space, a black hole can form regardless of mass. While the energy levels within the Large Hadron Collider are immense, comparable to the kinetic energy of a flying mosquito concentrated into the space of a single dust particle, they are still trillions of times lower than the Planck energy required by classic physics to create a black hole. Yet, the possibility remains because of string theory. If our universe contains extra dimensions beyond the 3 spatial ones we perceive, the energy threshold for creating a black hole could drop significantly. This means CERN might actually succeed in producing microblack holes. Even in this scenario, scientists remain confident that the planet is safe. According to Stephen Hawking's theory of radiation, these microblack holes would be incredibly unstable and evaporate in a fraction of a second, releasing a burst of energy no more powerful than a grain of sand hitting a hand. Even if Hawking radiation did not exist, these microscopic black holes possess gravity equal to only a few protons. Because atoms are mostly empty space, the likelihood of such a tiny object colliding with a nucleus is astronomical. It would take billions of years for one to grow large enough to threaten Earth, a timeline far longer than the remaining life of our Sun. Furthermore, Earth is bombarded by cosmic radiation every day at energy levels similar to those used by CERN, and the planet has survived for billions of years without incident. These experiments are not a gamble with humanity's future but rather a calculated step toward uncovering the deepest mysteries of our existence.